My name is Walter Alexander Nahara, and I am a student at California State University, Los Angeles. And these are my notes that I took for CS 4540, week 2 of lectures. So let's get started. Operations of a neural network. Now, a network behavior are dependent of the weights and biases. So weights are the strength of connections between neurons of same slash different layers. So if so neurons basically have a link between neurons within the same layer as itself and layers underneath them or behind them. Meanwhile, biases indicate the neuron activation slash deactivation values. Now, a type of neuron is called biological neurons. They're a type of node activation method where binary represents the neuron's activation slash deactivation status. So, so basically, zero represents when the specific node is off. Meanwhile, one indicates that the neuron is active. However, with the neural network that we're currently working with, the neur the neurons is actually got a fluctuate in values between 0 and 1. So so our neural network is not a biological, is not using biological neurons. Now, utter trash refers to when the data slash output of a given neural network returns as nonsense with no clear answers provided. So if you look at the image to our right, we input uh, an input of 3 written, and then it goes through the neural network. But because it activates multiple different neurons, it, the output doesn't give us 3 specifically. It gives us a wide range of like different um, outputs because they all technically are activated at the same time. Now, cost function is the mathematical formula that measures how well the network is performing by calculating the difference between its predicted outputs and the actual target values. Now, for our intents and purposes, we need to minimize the cost function, uh, which isn't as simple as finding the slope of any given like a slope that defines all outputs. Because as complicated functions often result in ungodly number of parameters with fluctuating height. So one single slope isn't able to calculate all the given parameters that we have in our neural network. So essentially what we do is we start at any random input and find the slope for that specific function. Uh, because it helps determine direction shift towards faster way to produce a lower output. So say if the slope that we were given is negative, we shift to the right. Whereas if the slope is positive, we shift to the left. Now, step sizes are proportional to the slope itself, meaning that steps taken become smaller and smaller as the slope flattens out to a minimum, which prevents overshooting our overshooting. Gradient in this case refers to a vector that represents the direction of steepest ascent in the quickest manner. And how we note this is by an upside down triangle. So an upside down triangle in C gives gives the upward direction, whereas a negative upside down triangle in C gives the downward direction. Gradient, gradient descent typically refers to the algorithm for minimizing the given function of a neural network in order to compute the negative gradient direction, take a step downhill and repeat that over and over. Negative gradients should have the same value of entries as the vector representing the weights and biases of the network with the purpose of pushing these values in a certain direction, so pushing it left or right. Each component of the negative gradient vector tells us 2 things. The sign which indicates where the corresponding component of the input vector should be nudged up or down, and the relative magnitudes of the components in the gradient vector, which tells us which of those changes matters more. So like some nodes would be more important to us than other nodes, and it's indicated by the gradient vector. What this essentially means is that network whirling just refers to changing the weights and biases to minimize a cost function, which improves the network's performance on the training data. Neural network, the neural network, despite being capable of recognizing single-digit numbers being shown and boasting a high percentage of correctness, failed in showcasing its ability to recognize patterns or parts of a corresponding number. Visualizing all 784 nodes highlights how the nodes are seemingly random regardless of their activation values, meaning that if the network were given an input of a static mesh, it would produce a clear answer instead of a confused or no answer, indicating that the neural network is using local minimum and associating it with the outputs. So the picture to our right is actually an example of when if you were to write a specific number in a certain way, then the neural network won't be able to correctly identify it as a specific number. So I got this from their website for 3 blue, 1 brown, where you can like mess around with like drawing the single digits, and then it'll give you the results. Now I drew a number 1, and to you and me, it's a number 1. But the neural network, because of those nodes and how it essentially correlated to specific outputs, is producing an 8, which is incorrect. Now this OOD, or out of distribution, refers to data that significantly differs from the data utilized during the training of the model. You're resulting in networks producing unreliable predictions. So because I drew this number 1 in a manner that was never picked up on the data, in the training data, then it will produce an unpredictable solution. Now, the second variable that we actually discussed was actually a lecture for a Nobel Prize lecture, which was performed by Demis Hassabis. He's the founder of DeepMind, a company who specializes in developing artificial intelligence programs. They're merged with Google Brain, a division of Google AI branch of Google, to become Google DeepMind. Now, his journey into AI began with being inspired by board games, so board games like chess. More specifically, early chess computers like the Fidelity Chess Challenger that he got access to while participating in a chess training camp that had access to these programs in order to allow their participants to play against these machines and then improve their skills. Now in the lecture, he gave us the reason why board games were determined to be the perfect proving ground for AI, and that which are 3 main ideas. They have clear objectives for the program to strive towards, the ability for these computers to play with each other, meaning that it has very little to no human interventions, and the generating data for these machines can be written down quickly. Now, AlphaGo is an AI program that was developed to play the Chinese board game Go, chosen due to being the most complex game with 10 to the power of 170 possible decisions. Now, AlphaGo mastered Go through self-learning, playing against itself and learning from its mistakes. And in doing so, it actually achieved quite a few important milestones in terms of the overall image of AI. For example, it beat Lee Sedol, the world champion of Go, in a match in Seoul in 2016 with a score of 4-1. It also developed novel creative strategy never conceived before, such as Persistent 34. Now, with that in mind, Demise decided to take what he and his team took what they learned and apply it to more important values, such as uh, important spheres. So in his lecture, he highlights how a suitable problem for AI has three main components: a massive combination search space, clear objective functions or matrix to optimize against, and then either lots of data and or an accurate and a sufficient simulator, which brings their team to protein folding problem or the protein folding problem. It, essentially, it's trying to it's predicting the 3D structure of a protein directly from its 1D amino acid sequence. Proteins fold into these complex structures that allow our body to be able to utilize that protein, as can be seen to the image to the right. The benefits of understanding how these proteins are structured will allow us to better understand diseases and accelerate drug discovery. Now, in an earlier Nobel lecture in 1872, Christian Efferson came up with the thermodynamic hypothesis. It essentially states that a protein will assume the conformation that minimizes the free energy in the system. Now, there are some difficulties with the folding problem. Standard procedures require experimentally determining a single protein structure, often taking years of painstaking work. It's also, and through the Leventhal paradox, which estimates that approximately 10 to the power of 300 possible conformations that a typical protein can take. This means that in enumerating all possibilities for a single protein would take centuries. Estimates indicate longer than the age of the current universe, which is the perfect uh, which is the perfect problem for AI to come into the table and in order to quicken this procedure. Now, luckily, decades of experimental work produced approximately 170,000 structures that have been determined and collated in protein data banks, or PDB, which became the basis for training the AlphaFold models, AI programs developed for simulating how these proteins would be structured. CASP competition is the golden standard benchmark to test the best computational system for protein folding binarily or every 2 years since 1994. The critical threshold is that predictions had to be accurate down to the width of an atom or less than 1.0 average error to be of use to experimentalists. The Now, the AlphaFold models actually had a huge impact to the protein folding problem. At the current moment, it folded 200 million plus proteins that are currently known to science. Consulted with 30 plus biosecurity and bioethics experts to ensure the benefits outweigh any risk. 2 million plus researchers from 119 countries have made use of AlphaFold and accelerated process on a huge range of problems, including plastic pollution, antibiotic resistance, neglected diseases, structural biology, drug delivery, fertilization mechanisms. Demise also highlighted criteria when it comes to advancing AI responsibly, and they include AI has incredible potential to help with humanity's greatest challenges. AI must be built responsibly and safely and be used for the benefit of everyone. Critical to engage with a wide range of stakeholders from government, academia, and civil societies. Technology as transformative as AGI requires exceptional care. And these are the resources that were used during the lecture and what I use to gain a little bit more information after the fact. And also the link to the website that has the same videos that I linked to, including some beneficial supplements that that allow me to interact with the neural network